Today's lesson is what I think is really fun. It is called polynomial long division. It is a way of dividing polynomials, and you have probably never thought about this before and never needed it before, but you can actually divide polynomials. And the way that we're going to do it is we actually have two different methods, and those are listed up here in the target. We are going to use long division, and we're also going to use synthetic division. There is also a third method, which I have never used, but I have watched a video on it, so I will post a video on the third method, which involves using the box method. So some people who really like the box method, there is a way of doing this using the box method. Before we actually get into dividing polynomials, it is helpful to remember how we do long division with just arithmetic like you did in elementary school, because we're going to use the same process. So right now, take a look at the problem that I have set up here, and this is a division. And take a second, do you remember how to do division? So pause the video here and see what you can do with your division. Okay, if you don't remember how to do division, then let me remind you. We have 7 going into 4,825. But at the beginning, we're not going to put it into everything. We're just going to look at, does 7 go into 4? Well, no, 7 doesn't go into 4. So we go over one more digit. Does 7 go into 48? Yes, it does. 7 times 6 is 42. Now what we do is we subtract. So we subtract this and we get 6, and we bring down our 2. Then we think about, does 7 go into 62? Well, yes, it does. It goes in 8 times, and that gives me 56. Once again, I subtract, so that gives me a 6 here, and I bring down my 5. Does 7 go into 65? Yes, it goes in 9 times. 9 times 7 is 63, and I subtract, and I get a remainder of 2. Now, you might not remember this, but what we do with that remainder is it's actually a fraction. It's 2 out of 7. So our answer, sometimes when we were in elementary school, we wrote down it was 689, remainder 2. But then we started to learn, hopefully, that what that means is 689 and 2/7. And remember, that's like there's a plus inside there. We don't usually write it as a plus, but that is a plus inside there. So that's a review on how to do it with arithmetic, how to do just basically arithmetic long division. We are going to do polynomial long division the same way. Now, one thing is out in the margin here, I do have listed where it appears in the Big Ideas textbook. So if you go to that page on textbook, there will be some information on this. I believe there's a video there, so that is another place for help if you get stuck on this. First of all, remember when we have these type of division problems, what we do is we put the x plus 3 on the outside, and we put this part of the polynomial on the inside. Now, when I write it on the inside, a couple of things. I want to write it in standard form. So I can see that my 2x to the third needs to go first. 2x to the third needs to go first. And then my 5x squared. And then my x term, which is a 0x. So I want to include that when I write it in there. And then my 12 goes last. So I'm going to take a second to write that in. Now, another thing about long division, and especially with polynomial long division, you have to just take a break and realize that we're just going to kind of do some approximation here. So when we do this, we're just going to say, instead of x plus 3, because that's a little bit too confusing, we're just going to say, does x go in to 2x to the third? So in other words, we're asking ourselves, what is 2x to the third divided by x? Even though there's a lot more after the 2x to the third, and even though we have this plus 3, we're just going to approximate. And we're going to say, well, what is that? Well, that comes out to be 2x squared. And basically what I was asking myself is just like I was with the arithmetic, is how many times does x go in to 2x to the third? Well, x goes in to 2x to the third, 2x squared times. Now, do you remember with the just regular arithmetic long division, now we multiplied 6 times 7 and got 42. That's what we're going to do here. We're going to multiply this. And we're going to multiply this and distribute it. And so I'm going to show my work over here so that you can kind of maybe follow our steps. This was the first thing that we did. The second thing that we are going to do is we're going to take 2x squared times x plus 3, and we're going to distribute it out. And so that's going to give us 2x to the third. That's what we wanted, good thing, plus 6x squared. Now, do you remember with long division, we then subtract those, right? So we're going to subtract these. When we do that, this cancels, good, that's what we want. This one's going to leave me with a negative 1x squared. Now I'm going to ask myself, okay, how many times does x go in to negative 1x squared? Or another way to say that is, what is negative 1x squared divided by x? Sorry, another thing we need to do is we need to bring that 0x down. And I think you guys remember that from elementary school. Okay, so back to how many times does negative x squared, how many times will x go into negative 1x squared? Well, it will go in negative 1x times. And if you're not sure what I'm talking about is what is negative 1x squared divided by x? And that, when I cancel that, comes out to be a negative 1x. Okay, now I'm going to distribute this, and so I get a negative 1x squared minus 3x. And remember, we now subtract. Negative minus negative is like a negative plus. Those cancel out. Good thing, that's what we want. Next thing, 0 minus negative 3. Well, 0 minus negative 3 is 3x. And then finally, I do need to bring down my 12. And then I'm going to do the whole process over again. I'm going to decide how many times does x go into 3x, or what is 3x divided by x, and that is 3. I'm now going to multiply this out, distribute it over to the side. That gives me a 3x plus 9. And remember, I subtract that. So I subtract that off. That 3x's drop off. 12 minus 9 is 3. So what I have is 2x squared minus 1x plus 3 with a remainder of 3. Or, the way we should write it is 2x squared minus 1x, or x, plus 3, plus, and I'm going to write my remainder as a fraction like I used to do in elementary school, 3 over x plus 3. That is how you do polynomial long division. I know that right now it seems kind of confusing. Hopefully, if you were decent at long division in elementary school, you'll be decent at this. Unfortunately, if you weren't decent at elementary long division, it's going to have a hard time with this. But again, page 174 has some more information, some more examples you can look at. I believe they've got a couple videos there, at least one video there. And we today are going to do some more examples also. But I'll save that for the next page, but we will do some more examples of this. Now, this next thing is actually not on your paper. Will you take a minute to write this down? And this is supposed to be a division. Because what we have above is dividing a polynomial divided by a binomial. We could also have it divided by a trinomial or a polynomial with 4 terms or whatever, but we stuck with, in this case, a trinomial divided by a binomial. Well, what happens when you divide by a monomial? This is much easier, and I hope that you remember how to do this. This isn't really something new, but we just should go over it just to clarify. Another way to write it is to write it over x squared, and then basically what we have to do is distribute our division. So that's what we're going to do next. When you have a division like this, remember you subtract the powers. So this answer is going to be 5x squared minus 8x plus 14. Now, some of you probably did not even need to write it out this way, and that's okay. If you don't need to write it out, don't do that. But I was just trying to show you how this works, and that's dividing by a monomial. Again, I think that you know how to do that, but I wanted to cover it just in case. Let's turn over to the other side. On the second page, we have our second option, that instead of doing long division, sometimes we can do synthetic division instead. Not always, but sometimes. Something to clarify, remember that when we have x minus 1/2, if we were going to find that solution would be a positive 1/2, right? We're going to need that information. So what we're going to do with synthetic division is I'm going to set it up like this. I put this little box in the corner. And then for my polynomials, and with the box in the corner, I put the positive 1/2 because this is x minus 1/2. But if we set it equal to 0, we get a positive 1/2. That's why I'm doing this. And with my polynomial, the rest of it, I'm going to take off my x's and just have my coefficients only. And a lot of people like synthetic division more than they like long division. However, it's a little bit backwards of a lot of the rules that we learned. So the first rule that's kind of backwards is the first thing we do is we bring down our 8. Then we multiply these. 1/2 times 8 is 4. And then the other difference is we are actually going to be adding these lines together. So -6 plus 4 is a -2. And now I multiply again, and that's a -1. And now I add these, and that is a +6. Now when you look at this, you have to figure out, well, what do these numbers even mean? Well, you always start at the end, and this is your remainder. This is your linear term. This is your x term. The next will be x squared, the next will be x third, etc., etc. So in other words, this is 8x minus 2 plus 6 over x minus 1/2. Another way to think about what x's go in here is if I have at the top an 8x squared divided by an x, well, that gives me an 8x, right? It's going to reduce my exponents down by 1. And so that's what I did there. All right, I'm going to set up my next problem. I have a +2 in the corner, 5, 2, 0, because there's no x squared, -20, and -6. To start, I bring down my 5. 2 times 5 is 10. With synthetic division, we add. So that gives me a 12. 2 times 12 is 24. I add. 2 times 24 is 48. I add. 2 times 28 is 56. And I add those together. All right, let's talk about the variables and everything. So it was x to the 4th. It got divided by x, so it went down 1. And so this should be 5x to the 3rd plus 12x squared plus 24x plus 28 plus the remainder, which is 50 over x minus 2. Let's think about how to do those variables a different way. The last one is your remainder, and then your linear term without an x on it, and then the x, x squared, x to the 3rd. But basically when you're dividing, you're lowering everything by 1 power, so that's why we have those exponents on those x's. And that would be my solution, my answer for this. Now again, if you are confused by what we're doing, it is in the textbook. You can go to this page and find some examples. I believe they have a video for that as well. And then also, if you are a fan of the box method, I have a video posted for the box method. Well, as we do these, something that's just kind of a really neat little side note is when you do this and you get the remainder, that remainder actually tells us something. So what that tells us is listed here. This is the remainder theorem. They have this listed out in the Big Ideas textbook on page 176. This graphic is actually from the old textbook that we used last year, but it has the same information. The interesting thing about the remainder, and this really is just an interesting thing, and above and beyond that, why do you ever need to know it? Well, it might be a shortcut. That's why you would want to know it, is it might be a shortcut. So the interesting thing is, if you're dividing by x minus 3, that really is like a +3, right? What this means is if I plugged in a 3, it would come out the answer is 7. It's just kind of a nifty little side note. It doesn't really, other than that, it's no new information. So again, you might say, well, why would I ever want to do that? Well, maybe the synthetic division, maybe that's easier than plugging in. But over the margin, I wrote down here, this is really just an alternative to plugging in. That's all it is an alternative to plugging in. Let me show you what I mean. If I set up my problem, now this time I don't change the sign because we're asking for f of -4. So the -4 is actually the -4 because remember when we were up here, and it was like x minus 2, I put a positive 2. But with this remainder theorem, f of, we keep that sign the same. So this will be another example for you to practice with synthetic division. We bring down our 1. We multiply. We add. We multiply negative 4 times negative 4. That's a positive 16. We add. We multiply negative 4 times 11. That's a negative 44. We add. And we multiply those together, and that gives us a large number, but it's 160, not too bad. And we add those numbers together. Remember, that number on the end, that's the remainder. And for this problem, that's all we care about. We don't really care about these, although I might in just a minute go back and remind you what those mean. So that is the remainder. So what it means is f of negative 4 is equal to 172. Now, all that is just an alternative to plugging it in. And I will tell you, if you plugged in negative 4, if you plugged in negative 4 into this equation, negative 4 to the 4th minus 5 times negative 4 squared plus 4 times negative 4 plus 12, you could put that into your calculator. And if you put that into your calculator, you would get 172. All it's saying is it's just another way to do that. Which one's faster? I don't know. It just depends on which one you like better. Once you get used to synthetic division, this one might be faster. But if you're good with your calculator and you want to do it this way, that's fine too. So it's not really, it's just a little interesting side note. That's kind of all it is. Okay, we will work more tomorrow on working with this division, both synthetic division and long division. And if you are a fan of the box method and you want to know how to do this with box method because you think that might be easier for you, watch the other video that I have posted on the box method. But in class, I'll tell you in class, I'm going to be doing synthetic and long division. But box method does work for all of this stuff as well.